Today we'll be talking about mass spectrometry. The sample, which is the organic compound, is placed in a mass spectrometer and bombarded with electrons, and this causes the molecule to lose an electron to form a molecular ion. And the notation for a molecular ion is an M+. And the molecule that will be turned into this, for example, could be ethane. So it being turned into a molecular ion would form CH3CH2 plus E minus. To find the relative molecular mass of a molecule through a mass spectrum, which would look like this, is by going to the M+ peak, which is this. This is the M+ peak. Let's say it has an NZ value of 34. That means that this molecule has a molar mass of 34 g mole to the raised power -1. The peak right beside the M+ peak is the M+1 peak, and this is generally formed from an isotope. And an example of this, in this case, would be a carbon-13 isotope forming an M+1 peak, which is normally normally really tiny, so we don't need to pay too much mind to it. So why this is important is because two molecules can be differentiated through this process because of fragmentation. So basically, fragmentation in a mass spectrometer, the bombarding of electrons make the molecular ion break down into smaller pieces known as fragments in a process called fragmentation. And the other peaks on the mass spectrum are caused from fragment ions making a fragmentation pattern. The simplest fragmentation breaks a molecular ion into two species: a positively charged fragment ion and a free radical. So this could be shown in an example such as this, which would break it into a CH3 plus ion plus a CH3 radical.